Hello, my name is Braden Hinsey, and I am excited to share with you guys my research on the variation in chronic depth electrode design and how it decreases cortical injury and apoptosis in a mouse brain. Um, Mitigating brain injury induced by chronic depth electrodes used for neurostimulation plays a crucial role in maintaining effective neurostimulation. The current study contrasts cortical damage caused by distinct depth electrode designs by quantifying the impact of implantation on tissue injury and cellular apoptosis. For these studies, we used a mixed C57BI-6 and SV129 genetic background mouse model. We specifically wanted to look at the difference between two intracortical depth electrode designs. The first design, as shown here, under this microscope. Design A used a bare platinum iridium wire core surrounded by deactivated fused silica. Design B was composed of a PTFE-coated platinum iridium wire core, only partially surrounded this time by deactivated fused silica. The deactivated fused silica entered the substance of the brain in the Design A model, but not in the Design B model. The complete head stage included 4 stainless steel screw electrodes for recording EEG and 1 depth electrode of each design for stimulation. As you can see here, this is a similar head stage with 4 stainless steel screws for recording as well as the depth electrodes. The head stages were surgically implanted into the mice and the brains were harvested 5 days post-operatively. The implanted brains were then fixed and dehydrated and then sectioned coronally and collected at the level of the hippocampus. I then stained the sections with floral jade C, Nu N, GFAP, and crystal violet. And then using a nanozoomer microscope, they were imaged. As you can see here, this is the Nu N and GFAP images, some of the images that are taken. On the left, you see the type A design, and on the right, you see the type B design. As you can see, off first glance, the type B design has a significantly decreased amount of cortical injury as shown here. You can also see there are far less activated cells shown by this bright green and bright red color in the type B design than in the type A design. We also looked at floral jade C staining and crystal violet staining as shown here. As you can see, once again, the type A design is on the left and the type B design is on the right. And the type B design caused significantly less damage. As to quantify these results, we used the floral JC staining, and we specifically did the following. For each electrode, the floral JC positive cells were counted from 2 or more sections within bilateral 0.125 millimeter squared areas drawn symmetrically and equally spaced around the injury tract, as shown here in these images. The type A design showed a mean of 9.5 with a standard deviation plus or minus 6 apoptotic cells within the given area, whereas the type B design showed a mean of 14.8 with a standard deviation of plus or minus 7.2. The p-value for a 2-sampled unequal variance t-test was 0.018 for an N of 5, demonstrating statistical significance. Thus, the type B design was associated with a significantly lower rate of apoptosis and brain injury than the type A design. These results provide insight into the effect of different invasive EEG electrode designs on tissue and cellular injury. I would like to give my acknowledgments to the Department of Neurology at Washington University in St. Louis, as well as the Department of Neuroscience at Brigham Young University, as well as Thomas J. Fouts, Nicholas R. Rensing, and Laurent Hahn. Thank you.